Okay, so in this example, we want to solve this initial value problem with this differential equation, 4y double prime plus 4y prime plus y equals 0. And we have initial conditions, y of 2 is negative 6 and y prime of 2 is 4. And so this is a second order linear homogeneous differential equation with constant coefficients. And so the way we're going to solve this is we're going to first find the characteristic equation, which we can just read off of the coefficients here. So we get 4r squared plus 4r plus 1 is equal to 0. And so now we want to find the roots of this, solve for r. We can actually factor this. This is actually square of a sum. So this is actually 2r plus 1 all squared. Now, if you couldn't figure that out, you could actually just use the quadratic formula. You would arrive at the same result. We would get r is negative a half. Notice there's only one root here, so this is actually a repeated root of negative a half. And so our general solution is going to look like this. Y of x is a constant times exponential to the negative 1/2 times x. And for the second exponential, we have to add an x in front of it, negative 1/2 times x. And this is our general solution. Now we have to find the particular solution using our initial values. And so we get y of 2 is negative 6. Y of 2 is negative 6. And so if we plug in 2 into this function, you can see this exponential will become negative a half times 2, or negative 1, e to the negative 1. Same with this one, is going to be e to the negative 1. And so on the left-hand side of here, we'll get c1 times e to the negative 1 plus, well, we have c2 times 2, because x is 2, times e to the negative 1, and that's equal to negative 6. Now I can simplify this a bit, so by multiplying both sides by e. And so I'm going to get c1 plus 2c2 is equal to negative 6e. Now for the other initial condition, it's the derivative at 2 is going to be equal to 4. And so we're going to need to take the derivative of our general solution here. So we get y prime of x. And for the first term, we use the chain rule. So we bring the negative 1/2 into the front, c1 e to the negative 1/2 times x. But for the second term, notice we have a product of two functions, x and then the exponential. And so we have to use the product rule. So that's what I'll do here. First function times the derivative of the second, negative 1/2 e to the negative 1/2 x. Second function, derivative of the first. There we go. And I evaluate this at 2, I should end up with 4. So y prime of 2 should be equal to 4. If I plug in 2 here, again, this becomes e to the negative 1, e to the negative 1, e to the negative 1. And so let's see, we got to make sure whenever you have a whole bunch of terms, you got to make sure you don't make any arithmetic mistakes. So the first term becomes negative 1/2 c1 times e to the negative 1. The second term becomes c2 times 2 times negative 1/2 e to the negative 1. And the third term becomes plus c2 times e to the negative 1, and that's the whole thing is equal to 4. So again, we can simplify this by multiplying everything by e to cancel out all of these, and also sort of clean up. So, right, these two c2 terms can be collected together. So I'm going to try to do this all in one step here. So I get negative 1/2 c1. So here I'm going to get minus c2, and here I'm going to get plus c2. And so actually what I'm going to end up with, those are actually going to cancel each other out, and I'm going to end up with, well, I have 4e because I multiplied everything by e. And so I get negative 1/2 c1 is equal to 4e. And so in other words, c1 is equal to negative 8 times e. And then, now that I've solved for c1, I can plug that back into this equation over here to solve for the c2. So I have c1, which is negative 8e, plus 2c2 is equal to negative 6e. So if I move the negative 8e to the other side, I get 2e. And so c2 is equal to e. Okay, so now we have our two constants. And so now we can plug it into our original general solution to find our particular solution. So here we go. Let's move it down here. We get y of x is equal to c1 negative 8e times e to the negative 1/2 x plus c2, which is e times x e to the negative 1/2 x. Now that's a final solution, but it's kind of a little messy. I can simplify it by combining the exponentials together. So I can write it as y of x is negative 8. Negative 8 stays in the front, but e times e to the negative 1/2 x. Right, by the laws of exponents, we get e to the 1 minus 1/2 x. And then over here, I can rearrange the order. So I multiply e and this exponential. And again, I get e to the 1 minus 1/2 x. And so there you go. That is your final solution.